Hello, Ken Weller here with New Tech Inventors, and I'm here today to talk to you about this little 3D printed part here. Looks pretty simple, but this part is going to save me a lot of time and money at my new 3D print farm. And I think it might be something beneficial for a lot of you out there viewing. So I'm going to do this video. I'm going to show you how I came up with the idea, what it's supposed to do, and I'm going to show you how I designed it, how I made it, how it works, the whole process. So I'm counting on some of you to give me some feedback and let me know what you think after you've seen this video, and I'll probably have to have a second video to show all of the details of making this device. And I'm sure a lot of my reliable viewers out there, Joe, Shane, Alan, Paul, Andrew, Robert, Kevin, you guys know who you are. You always comment on ideas that I have, and I take all the comments that people provide me with very seriously. They actually help me change designs and stuff and give me ideas, things I hadn't thought of. So I appreciate all of that. I like the way that we seem to have a family of 3D printers out here that work together constructively. So anyway, let me get on with it. Okay, I'm going to show you a few clips of going through the process of making and printing this part, and then I'll explain how I came up with the idea. Okay, a little bit about what goes on at New Tech Inventors. Get an idea, and we come over here and we go to our CAD software and then to our slicers, draw these parts out. Then in my office, I have 3 King Room printers that I talked about before that I use for doing my prototyping work. This is one King Room here, the main one that I use. And this is the first prototype that we printed, and this is the second modified one. And then over here is King Room 2. This is the next printer that I use, and it's printing the part for the spool holder. And this is one of our helping hands with the floodlight attachment on it, which is an extremely bright LED. I happen to use this helping hand just to give myself extra light over here when I'm printing these jobs. It really helps me see what I'm doing. So, and this is the arm that I'm printing for the manual crank, which is a temporary way to pull the filament through until I get the motorized version fixed. Here's King Room 4. He's here on standby on my desk. If I need him, I'll get him up and running. Went and scrounged a bunch of parts. I have, these are pretty powerful 12-volt motors, and I have several of those. I also went and looked up some other magnets. I've got some different round magnets here. And right here's our contact switch. So, and then we're just taking some of these little acrylic stands, had a bunch of them that we haven't been using, and we're going to use those temporarily to get this prototype working, to see how well it's going to work. Also coming back around, let's see, there's a counter here. Yeah, this is the counter we're going to use. Now I've assembled this part and made a prototype, And it looks like everything is working as planned. So first of all, coming up with the idea, many of you that have watched some of my videos know that I've done several videos that include care of filament, trying to keep moisture out of your filament by using silica gel packets and vacuum sealed bags and so forth. Filament, and I did a little video. I don't know if I didn't include it in this one or not, but I'll show you how I vacuum seal these things. The problem I have now that I've built this print farm and I have a large quantity of printers there, and within the next 30 days we'll probably have up to 60 printers. And most of my parts that I print, especially for the helping hand, are orange or black. And since those are the primary colors, that means that every time I run those printers, I'm printing a lot of orange and black parts. What I have to do, and what I've been doing, if you look at the videos, you'll see me opening up 15 or 20 different boxes of filament and taking the filament out and cutting the vacuum seal packet free and loading the filament onto the printers and starting to print. Okay, and then we print for 12 or 24 hours, maybe longer, and then when we are through printing, we have to take those spools of filament off, get them back in a vacuum sealed configuration with gel packs in there to try to minimize the moisture. But the filament's already been exposed to moisture for 12, 24, 36 hours. So in that period of time, it's absorbed some moisture. And there's a big question in my mind I had about, well, how big a problem is this moisture problem? Well, I found out that it is a problem that affects printing. I was trying to think of some easier way to keep from having to go through that whole mess, and I had the idea, well, okay, if I could just take a new spool of filament and take off just what I need for my print job, transfer it to another spool, put it on that printer and print, then when the print job finishes, the spool is going to be empty. That way, I know I'm getting pretty fresh filament on it. So I did some calculations, and I found out that if I'm running 24 printers of orange PLA, the same filament on each one, I used to need 24 rolls of that filament. And in some cases, I would be using new rolls of filament. So you're taking 330 meters per spool. That's 7,920 meters that you're opening up and committing to using. Now, with the 24 printers running 12 hours, they consume an average of about 25 meters per printer. And if I took 13 printers, I can get enough filament off of one new spool of filament to run 13 printers on a 12-hour run. So I would only have to open 2 new spools of filament instead of 24. And then I would distribute all of that fresh filament to spools that would then take that 25 meters of filament, put it on the printers, and let them run their 12-hour shift. And at the end of that, there'd be no filament to have to try to bag up and vacuum seal and all that stuff. And those print jobs should come out really good because they're all printing on fresh filament that just came out of the factory sealed container. So that, I felt, is going to make a big difference because you're only using 2 spools, no need to store unused filament. You've always got fresh filament, no wasted starter filament where I used to have to pull off the first couple meters or something and discard it because I was afraid it might give me problems starting a print job. And you get more consistent prints. The prints are going to all be coming out about the same because they're all using the same filament off the same spool, and they all have the same freshness. They've been out of the box for less than 12 or about 12 hours by the time they're finished printing. So the next thing was, okay, how do I do this? Okay, and this is when I came up with the idea. And this is the page that I put my idea down on. And what this is, it's a motorized device that will take a new spool of filament and run it through this device. The filament goes in this hole and comes out this one. And then it goes on to a take-up spool. And the take-up spool is motorized. And it also has a guide that goes back and forth that will help wind the filament onto the spool in a close, consistent format, which will help prevent it from getting hung up later on when it's despooling into the printer. This device is actually the brains or the counter. This thing is going to detect and determine exactly how many meters, how much filament is going on to this empty spool. And the way that's done is I did a little more research into designing, and this is where I did the design work, which actually led to this CAD drawing that allowed me to print this part. And this device will be eventually, right now in the prototype stage, it gives me a digital readout. It works on pulses, and it then I can take that and, for example, 16 pulses are equal to 98 centimeters, so just shy of a meter. And I'm eventually going to fine-tune it a little bit and probably use something like an Arduino board to be able to put in how many meters I want to take off my new spool and put on my empty spool. And then the machine will automatically start winding. Well, you have to feed the filament and put it into the empty spool, and it will automatically start filling that spool with 25 meters, 30, 75 meters, whatever you need for the print job, based a lot on how long it's running. And when it gets to that point, it will stop, and then you will have to remove that spool and put another empty spool on and start it again. And if it's another printer that's running the same job and time, then you just use the same settings and restart it. If it's going to be a different quantity of filament that you need on the next spool, then you can change the count on the input device for this counter. So the way that's going to help me is that I run a lot of printers running the same parts during the same period of time. I use a lot of the same color filament. My primary colors with the helping hand are orange and black. So I have a lot of orange and black running. And as I schedule my jobs, I talked about that a little bit in the last video, but to schedule these printers and everything, I'm going to have to know that I can get down there. Again, you got to remember, this is a one-man operation. I've got to do this all myself. So I have to go down there, walk in that room, and I may see 20 or more printers that have finished printing, and I have to remove the filament, reload and restart them. Or if they're going to continue on and do another cycle, then all I have to do is remove the parts and restart them, and I'll have enough filament on the spool to run that job. For example, if I'm running a job that takes 12 hours to print on a printer, but I'm scheduled to run that for 4 days, then that's actually 8 12-hour cycles. So I'll go down there in the morning, remove parts, restart it, go down there in the afternoon, remove parts, start it, and back again in the morning. That will be my task for that specific printer. And when it does come time to change colors, when the printers are going from orange, some of them are going to be starting to print black parts, then I have to remove the orange filament and store it. But in this case, I've already predetermined that, so there's only going to be a meter or so of filament left on that spool, and I don't have to worry about that. I just take that spool off, throw it in the bin, and grab the spool of black that I'm going to be using now and put it on the printer and pull up the job and get it started. So not having to fool with different spools of filament, and by only using what I need, it's going to really help me. And the time, some of you may say that, okay, that's going to take you some time to put the filament, take a roll of filament and put empty spools in and load them up with quantities. But it's really not. Everything's going to be automatic except for taking the spool once it's filled and putting another empty one in and continuing on with the process and putting in the length that you need. So I really don't think it's going to take that much time. The time that it takes to do that is going to be a lot less than the time that I've been spending trying to take these spools off the printer and then get them and put them in a vacuum seal bag and seal them up with gel packs, and then the same thing when it comes time to print or something. I've got to take them back out of those bags, and then I've got to cut off the leading part of the filament to keep it from going into the printer, because by that time, like I mentioned, it does get brittle there toward the end. The print quality is important. If you have some bad parts that you've got to reject because of your filament, that's not a good thing. You've wasted a lot of filament and a lot of print time there. So that's the reason for this. And this little thing right here, I'll be showing you on the next video how it actually works. And we'll run some spools through. Right now I don't have the motorized section of it built. I'm going to be using steppers, so to demonstrate it with prototype, I'll be using a hand crank take-up spool so I can pull the filament through and get my counts and then verify that it's counting correctly.